number 2 is called Cityscape, and basically it's about Sanjay, who is trying to look for a cityscape to use as the background of his new profile picture. So basically, he's given a list of the heights of some buildings in a row. So like this, I've copied in the first input here. So like there's 6 buildings in a row, and he wants to choose the longest consecutive series of buildings that form a mountain formation, where a mountain formation means that like the heights of the buildings strictly increase from left to right up until the peak, and then strictly decrease from that point on. So for example, in this case, this 2542 segment would be the length of the longest, or like the longest mountain formation, which has a length 4, so we would output 4. Let's just look at some other samples. Here we just have 432. So it says that it doesn't matter if like one side has no mountains, it's still like 432, it's still like peak and then decreasing from then on. So it's length 3 mountain, and if we just have 1, it's just the peak by itself, so that's a length 1 mountain. So here n is 100,000. So like if we try to do something where you consider every left point, and then looking at what the longest mountain that could extend from that left point on to the right is, then that would take like probably n squared time, right? Because there are n starting left points of buildings that you have to consider, and then like each mountain formation could be of length up to n. So then that would be like n squared. I think like going off of that, you could have like a smart 2-pointer solution, but the solution I came up with is, I think it's like simpler than that. So basically what we can kind of take advantage of is like the symmetry that there is about the peak. So basically we can just actually consider every peak instead of considering every building being the leftmost building, we consider every building being the peak of a mountain. So let's say that like if we're considering this 4 being a peak, then the length of the longest mountain formation where this 4 is the peak is basically the sum of, or like the length, like the farthest you can go to the left and still be like strictly decreasing, plus 1 because of the peak itself, and then plus the length of the how far you can go to the right while still maintaining the like strictly decreasing property. So here 4, you'll have like 0 to the left plus 1 plus 1, because you can go 0 to the left and then 1 is itself, and then you can go 1 to the right. Then if you keep going, then you get to the 5, which breaks the mountain. For this 2, you can only have like a mountain of length 1. And this 5, you can go 1 to the left, you have 1 at itself, and then you can go 2 to the right. The 4, 2, but then this 2 is no longer strictly decreasing from this 2. So if you go to so the 5 would have length 4 mountain, like the 5 as the peak. If this 4 is the peak, you would have like, you can go 0 to the left, 1 is itself, and you can go 1 to the right. So that's 2. It's 2, the answer is 1. If it's 2, the answer is 1. So basically, then the problem just becomes like, can we, for every peak, know how far to the left we can go and how far to the right we can go? Because if we can compute that for all the peaks, then we can just go through every peak and then see which has the max left plus 1 plus right, and then that would be our answer. So we can kind of do that using like it's kind of like a prefix sums / like DP technique, where basically we're gonna have an array. Okay, so let's first think about how we would get how far to the left you can go. So it's pretty clear that for the leftmost building you can go 0 to the left because there's nothing to the left like at all. So you just can't go there at all. So the left value for the leftmost building is 0. Then as we iterate through the indices in increasing order, the left value of like the current building I will depend on the value of the previous value. So here, depending on whether the current building is taller than the previous building, we update this value. So in this case, the 2 is less than the 4. So that means that the value of this 2 is just 0 because it can't go to the left. But on the other hand, say we get to this 5 and the 5 is greater than the previous thing, which is 2, then the left value for this is the left of the previous value plus 1. So 0 plus 1 is 1. And that's because like you can we know we can travel to the left from this to this, and then from then on we can do whatever we could do there, right? That's why we take like what we had before and then just add 1 to it. So yeah, we just continue this process. So 4 is less than 5, so it's set back to 0, and then these are both 0 because 2 is not greater than 4, 2 is not greater than 2. And then we have to do this pretty much a similar concept for the right. So this time we start from the right, right? So obviously for the rightmost thing, it can go 0 to the right because there's nothing to the right of it. And then here we look at if the current building is higher than the next building. So here 2 is not greater than 2, so it's actually like 0. 4 is greater than 2, so it's 0 plus 1. And then 5 is greater than 4, so you take this number and you add 1 to it, so this is 2. 2 is not greater than 5, so it's 0. 4 is greater than 2, so you take the value for the 2 and add 1. So the 4's right value is 1. So does anyone have any questions so far about like the logic used to compute these left and right arrays? Like how far to the left and right you can go from each peak? Okay, so I think here I would just start coding the solution. I think the rest of it is like implementation that we can figure out on the way. Okay, so let's first begin the input. So n is like just the first int, and then we have an array of size n. Okay, so now we basically need to compute to store these two arrays, left and right? So for the first, to compute the array left, let's review the logic we just did. So the left value of index 0 is just always 0, which is pretty convenient for us because like that's the default value of an array, 0. But I'll just like make it more explicit by just pointing out that base case. Left of 0 equals 0. So now we're going to go through the rest of the indices starting at 1. And then the value of left of I will depend on like the comparison between a of I and a of I minus 1. Right? You need to compare the height of the current building with that of the previous building. So if a of I minus 1 is less than a of I, that means that like the current building is taller. Then left of I is the left of I minus 1 plus 1. Because that means that the plus 1 comes from being able to move from the current building left 1 to the previous building. And then from there, you can do whatever you can do from there, which is left of I minus 1. And otherwise, left of I is 0, because that means you can't move to the left at all. And then it's pretty much the same thing, very similar logic for right. I'll just make this base case explicit again. So right of n minus 1 is 0 because you cannot move to the right from the rightmost building. And then now we're going to go through the rest of the indices. So like n minus 1 is the last index, so n minus 2 is the second last index. And then we're just going to move to the left from there. And then very similarly, we will compare the current building to the next building. So like if our current building is higher than the next building, then we can move to the right toward that. So we have right of I is right of I plus 1 plus 1. Otherwise, it's set to 0 because we cannot move to the right. Okay, so we have left and right computed, and now all we need to do is compute the answer. Here we know that ants, like we can use an int because the maximum answer, right, is just possibly n, because like the number of buildings is capped at n, and you can't have more than the existing buildings in the answer. So we know that like ant is capped at n, which is 100,000. So now we're just gonna go through all the buildings and consider each one being the peak. So when the current, and then like max that of course with the answer itself. So we're gonna max answer with itself, and so now in this what I'm typing here will have to be what the length of the longest mountain we can construct with I as the peak. So it will be just left of I plus 1, right? Like how far to the left do you go? you can go then +1 because that's the current building, and then plus right of I. And then after all of that, the answer will be the optimal answer. So we can just print it out. Okay, so pass the sample test case. Okay, it's accepted. So do you have any questions over this? Okay, so next, Andrew will present the solution to problem 3.